Archaeologists name eras the Bronze Age or the Iron Age. Well, what of the metals these periods are named for? Copper, bronze, and iron all seemed to play an important role at Tel Akko, and the Penn State University of Haifa Tel Akko project collaborated with the Weizmann Institute to investigate metal production at the site. Adi Eliyahu Bachar, a postdoc at the Weizmann Institute, came to Akko to investigate iron manufacturing. She explains two of the methods used to identify iron and other metals.
This is here and the X-ray is here. So X-rays are much more energetic than infrared radiation. And the infrared, as I said, is similar in its energy to the energy that the bonds are vibrating inside the molecules and compounds, whereas the X-rays penetrate the crystals in a different way.
In the small lab set up near the dig site, Adi has equipment to test samples using infrared spectroscopy and, for one day, X-ray spectroscopy. She will also take samples with her for additional spectroscopy and microscopic studies. Two students from Penn State, Jessica Wells and Brady Liss, are helping Adi and earning credits in the process. However, metallurgy studies don't begin in the lab, but in the field. First, the students mark locations on the various strata, or levels, that were uncovered last year in an area where iron hammer scales were present in the earth. Brady and Jess took samples from all of the marked areas. They then collected samples from the next area to the east that was excavated this season, especially for the metallurgy project, this time taking samples from the surface. Samples are collected in small bottles, carefully labeled with the location and taken to the lab. Iron slag cakes and pieces of iron slag were also collected for future analysis. Back in the lab, Adi explains the procedures.
I take a lot, much more than I need on calcium weighing paper, and then I start gently crush it, homogenizing a big amount of sample.
Adi continues explaining the procedure near the infrared lamp that is used to dry the potassium bromide used as the carrier for the samples, and to dry the mortars and pestles when they are cleaned. Next, it was time for the students to try their hand at preparing samples. Here, Brady grinds up and homogenizes the sample. After removing most of the sample from the mortar to be replaced in the sample bottle, he reduces the sample amount to a tiny dot. Next, the sample, mixed with potassium bromide, is placed into a capsule that fits into a hand press. This is the tricky part, because if the capsule is jostled, the sample must be remade. If the students were lucky, the sample came out looking like this and was placed in the FTIR machine for analysis. If not, it went back into the mortar to try again. Brady and Jess may not have always been successful in sample preparations, but they now know how to collect samples, process them, and search for iron or copper.